Thank you. May Lord Ganesha and Goddess Saraswati bestow their blessings and make this event a great success. If you have a dream, don't just sit there. Gather courage to believe that you can succeed and leave no stone unturned to make this a reality. A dream does not become a reality through magic. It takes sweat, determination, and hard work. Finally, the most awaited moment for which we all have gathered here today and which we all have working tirelessly since long. It is here. That is the formal inauguration of Life Sciences Society of Deshbandhu College. On behalf of the entire Life Sciences family, I request our esteemed chief guest, Dr. Ajay Kumar Singh, and our honorable principal, sir, to officially inaugurate the society as we have gathered here in virtual mode. So, sir, please permit us to follow up the procedure digitally. Sir, do we have the permission?
Please, you're permitted. Go ahead. No sound, I see.
The sound is not there.
Heartiest congratulations to entire Life Sciences family and everyone present here. So now I feel grateful to have the presence of our dynamic principal, sir, a person who is an inspiration to all. He has given us the path to follow and to make our dreams reality, and given the firm foundation for all young minds. He's a role model for all the teachers and the students for the incomparable hard work which he practices in daily life. I would now request our honorable principal, sir, to welcome our chief guest of the day and address the gathering with his words of wisdom. Over to you, sir.
Thank you, Vikram. Very good morning and namaskar. Dear friends, students, and colleagues, a warm welcome to you all today to this inaugural event of Life Science Society Synergia. We have amongst us today Professor Ajay Kumar Singh, Director General, Life Science DRDO, in delivering the inaugural address. We welcome you, sir, to our college. Students, it was a long-standing demand of life science students to form a society for them. Finally, their demand has been accepted, since at many places decentralization is necessary for the better outcome. Now this has to prove by you, my dear students. I express my thanks and congratulate to founder convener, Dr. Manisha Sanger, co-conveners, Dr. D.K. Malik, Dr. Deepti Gupta, conveners rather, Dr. D.K. Malik and Dr. Deepti Gupta, my apology for naming them wrongly. Co-conveners, Dr. Vaishali Thakral, Dr. Anju Chipper, and Dr. Kiran Bala, for being instrumental, initiating, and finally come to a logical end of forming this society Synergia. We all have a lot of expectations from Synergia, and I'm sure this will become one of the best life science society in Delhi University. Friends, as far as today's topic is concerned, I have written a small paragraph for this. The life science industry research body becomes increasingly expensive today. Many experts discover that some conditions are inherited through genetic coding. This implies that healthcare can be more customized based on DNA information or other genome features. This ushers a new era of personalized medicines and healthcare procedures. Many researchers have now focused on various life sciences branches, such as immunotherapy, precision surgery, and genetics. So it is the most thriving of all life sciences branches, so to speak, when it comes to cope and protect life in general. I hope we all will be more enlightened soon by our guest speakers today, Professor Singh, in this matter. Before I end, I would like to thank again to all the members of Life Science Society, all the students who have been involved in this, all the conveners, co-conveners, our IQAC coordinator, Dr. Aditya Saxena, Dr. Monica, Dr. Anjana, for providing all necessary support for holding this event online. My best wishes to Synergia again. Thank you very much.
Thank you so much, sir, for the congratulations and your words of wisdom. Now, I would like to call Dr. Dharmendra Kumar Malik, sir, to welcome our guest of honor for today. Over to you, sir.
Thank you, Vikram. A very good morning to one and all present here in the inaugural ceremony of our newly formed Life Sciences Society, Synergia, a beautiful name which is a reflection of focusing all the energy together into one. Honorable Chief Guest and a speaker of our first inaugural talk, Dr. Ajay Kumar Singh, sir, respected Principal, Dr. Rajiv Agrawal, sir, my esteemed colleagues, and dear students. I feel proud of being a part of Synergia, and on behalf of the society, extend a very sincere warm welcome to you all present here. It's our pleasure to have a distinguished scientist and Director General of Life Sciences, DRDO, Dr. Ajay Kumar Singh amongst us to grace the occasion. Thank you so much, sir, for accepting our invite out of your extremely busy schedule. Sir, on a personal note, I would like to acknowledge and thank DRDO in mass for helping me to use gamma cell facilities during my doctoral work in 1990s. I tell the students about the advanced biophysical and biochemical research facilities available in mass and this part. And with your blessings and permission, sir, our students would like to visit the institutes and get motivated and benefited by this. I appreciate the initiative of our dynamic principal, Dr. Rajiv Agrawal, sir, who encouraged us to form a life sciences society. Sir, it's a dream come true for the life sciences students. It could not have been possible without your constant guidance and support. Thank you so much, sir. Without taking much time, once again, I would like to welcome you all and wish our students a great success in taking the society to a great height. Thank you.
Thank you so much, sir. Now, I'm elated to welcome Dr. Manisha Sanger, our founder convener, to felicitate the honorable speaker and the gathering. Over to you, ma'am.
Thank you, Vikram. A very good morning to our guest of honor, Dr. Ajay Kumar Singh, our respected principal, sir, Dr. Rajiv Agarwal, teaching fraternity from different colleges, my colleagues, and dear students. It's a matter of immense pride for our institution to have amongst us Dr. Ajay Kumar Singh, Director General Life Sciences, DRDO. What else one could dream of than having a manpower, excellence, and internationally acclaimed scientist for the inauguration ceremony of the Life Sciences Society. The man who burned the midnight oil for the defense of our country during this bio war against the deadly bioweapon coronavirus. We are indebted to you, sir, for taking out your precious time and gracing us with your benign presence. Today, my words are not enough to express my heartfelt gratitude for our very dynamic principal, sir, Dr. Rajiv Agarwal, who supported us in making this dream become a reality. My many principals in the past could not support this dream of students, but Sir has shown us the path and given us a firm foundation. We are really very fortunate, Sir, to be guided by you. Thank you so much, Sir, for your wholehearted support in the formulation of this society. I thank you. I also thank my IQAC coordinator who has been working day in and day out for our college to stand apart. Life sciences as a discipline classifies living organisms past, present, examines how they function in the light of organic and inorganic chemicals and their interactions with the environment. Thus, the curriculum provided by life sciences is interdisciplinary, an amalgamation of three trident subjects that provide an interface between them. The very idea of making a separate society for life sciences was inspired by the enthusiasm shown by the students. The students, sprawling with their knowledge of three subjects under one umbrella, could blend their ideas under these three domains of biology, that is zoology, botany, and chemistry, and sustain a broader view of the current cutting edge developments to think out of box. The society will help the students to tap their hidden potential, develop in them the organizational skills, help the students to express themselves and their overall development. They also will learn to inculcate the spirit of teamwork and event management. I know that the society, under continued guidance of our principal, sir, the conveners, the co-conveners, and the very hardworking office bearers and council members will leave a benchmark for the future generations to come. My sincere thanks again to our guest of honor, a man of this stature, spearheading our country's tallest organization, DRDO, for gracing us with his benign presence. Thank you, sir. Thank you so much. Over to you, Vikram.
Thank you, ma'am, for your kind words. Now I would like to call Dr. Deepti Gupta, ma'am, our convener, to share her words of wisdom and address the gathering. Over to you, ma'am. Am I audible?
Yes, you are audible.
Someone kindly unmute Deepti, ma'am. I request our co-host to unmute Deepti, ma'am.
Very good
Over
morning,
to you,
sir.
ma'am.
Yes, thank you. Thank you, Vikram. Thank you so much. Very good morning to our principal, sir, our Honorable Chief Guest, Dr. A.K. Singh, and our faculty members from Deshbandhu College family and from other colleges as well. And very good morning to all the students who have joined in today. So, sir, to start with, it's an immense pride that we are having Dr. A.K. Singh, sir, as a chief speaker for this inauguration of this Life Sciences Society. And so I would like to just give, though Dr. Manisha Sengar ma'am and Dr. Malik sir has already, told you about the society, but I just want to say in very few words that, the seeds for the Life Sciences Society were sown by Dr. Manisha Sengar ma'am right itself for the it was way back in last year, and due to some COVID issues and the situations involved, we could not obviously implement it. But then after sowing the seeds, it was watered by our honorable and very dynamic principal, sir. And he said, no, grow the seeds. I will help you out. And now the tree is here. It's a plant, I know. And we are trying to make it into a tree. And we are branches of this small plant. And I hope that in the future, we are going to have a very full grown tree with fruits. And I wish all the team members of the Life Sciences Society, all the hardworking students, that we are going to make it such a beautiful tree that in the future generations to come, people will remember that yes, under the leadership of Dr. Agrawal sir and Manisha Sengar ma'am and Malik sir, we could make it happen. So thank you very much, sir, Dr. A.K. Singh, sir, for giving us the opportunity to be with you and to listen to you. Thank you so much. And thank you, Vikram, for giving me the opportunity to speak a few words. Thank you, sir.
Thank you so much, ma'am, for your kind words. Now, I would like to take the opportunity to invite the Secretary of our Society, Ankur Bharadwaj of Life Science Second Year, to formally introduce our distinguished chief guest of the day. Over to you, Ankur.
Thank you so much, Vikram. A very warm good morning to one and all present here. This is Ankur Bhardwaj, Secretary of Synergia, the Life Science Society, Deshbandhu College. I feel very privileged and it gives me immense pride and joy to introduce our honorable speaker to all the attenders on this precious day of inaugural ceremony of our newly formed society. Sir, you hardly need any introduction. You have made all of us proud with your distinguished work in numerous capacities. You are one of the most celebrated dignitaries. There are no secrets to success. It is the results of preparation, hard work, and learning from failure. The one who justified this statement in true sense is our worthy speaker, Dr. Ajay Kumar Singh, distinguished scientist presently holding the charge of Director General, Life Sciences at Defense Research and Development Organization Headquarters, with effect from 1st October 2018. Prior to this, he was Director of Institute of Nuclear Medicine and Elite Sciences from 1st October 2015 to 30 September 2018. Dr. A.K. Singh also has vast experience in HR management and has been the director of 4 establishments of HR management in DRDO. That is, Center for Personal Talent Management from June 2007 to September 2010. Directorate General of Human Resource Development from October 2010 to 27th Feb 2013, and Directorate of Personnel, DRDO Headquarters from 28th Feb 2013 to 17th June 2015. Dr. A.K. Singh was born on 25th June 1961. He did his master's in biophysics from Punjab University, Chandigarh, doctorate from Jamia Millia Islamia University, Delhi on infection imaging, PhD in Human Resource Management from NIT Kurukshetra, and obtained Doctor of Science from MIT University. Dr. A.K. Singh joined DRDO in 1988 and worked on various research and development projects. During his 30 years of service, he has made significant contribution in infection imaging and internal decorporation of fission-produced radionuclides. He has developed a Diagnobac kit for detection of infection lesions. He has introduced and nurtured pharmacoscintigraphy, that is, application of nuclear medicine imaging in drug research. Dr. A.K. Singh is the recipient of many accolades and recognition of his various contributions for life sciences and HR management. Few to mention are Young Scientist Award in 1999, instituted by Brigadier S.K. Mazumdar Memorial Trust for development of ciprofloxacin kit for specific infection imaging. DRDO Technology Award in year 2000 for working on development of diagnostics, radiopharmaceuticals. Oration Award at Chandigarh Science Congress in 2012. Mrs. Thangam Vasudevan Award 2001 for development of a call kit for instant preparation of TC99M for fluoroquinolone for specific infection imaging by Indian Association of Biomedical Scientists, and DRDO Scientist of the Year Award in the year 2006 for his outstanding contribution in DRDO. Brigadier S.K. Mazumdar Oration by Society of Nuclear Medicine of India in 2016, and J.N. Mantra Oration by Physiology Society of India in 2017. In 2019, he was conferred with Distinguished Alumnus Award by Punjab University. He has 18 patents and 57 publications in various national and international journals to his credit. He has supervised many PhD scholars of India. He has been instrumental in taking various initiatives for HR development in the field of aerospace and aeronautics as a coordinator, Aeronautics Resource Panel. He has patronized sport with equal enthusiasm as President DRDO Sports Board. Dr. A.K. Singh is an Antarctican. He has participated in 19th Antarctic expedition. Sir, you're truly a source of inspiration. Now I would like to request you to commence your talk and enlighten us with your immense pool of knowledge. Over to you, sir.
Let me put my slideshow first. Welcome. DRD से जो scientist है, if he's in Delhi calling. If he's in Delhi calling. No, if he's in to put the slideshow. Dr. Manisha, just see whether any permission is needed to share the screen.
Okay, sir, I will.
Uh, Actually, we could see your screen, sir. Your screen is sharing, sir. It's there.
Now, and now can you see the slides?
Yes, sir. Yes, sir. We can see the slides, sir.
Okay, let's start now. Okay, good morning and namaskar to all of you. Professor Agarwal, the esteemed principal of Deshbandhu College, convener, co-convener, and certainly Dr. Manisha Chauhan, Nee Manisha Sengar, the founder, convener of this Life Sciences Society of Deshbandhu College, Synergia. I think let me first congratulate all of you for this initiative. And these are the initiatives which really add to the learning of all the young researchers who are the future of this country. When Manisha called me and she said that I have to, spare time and share my thoughts with all of you, I couldn't say no because Manisha, I cannot say no to Manisha because I know Manisha when she was going to school, and a very lovely and very passionate person. Thank you, Manisha, for giving me this opportunity to be with
Thank you, sir.
this Deshbandhu College fraternity.
Thank you, sir.
I think I'll take you to some of my reading, some of my thinking on how the life sciences landscape is evolving over a period of time. And when we talk of life sciences, I think I'll start with the human body. Humans. I think all of you would agree with me that human body is the most complex machine yet encountered by us. And this human body consists of trillions of cells, each containing billions of molecules, and which consist of tens of thousands of atoms. And these molecular machines perform their designated task with incredible precision, working with a stunningly interdependent environment from level of molecular communication with each other over minute distances right up to the organ system, what we say is our body. This is the complexity and the precision which we see, which we encounter in the human body. And the quest of human being to understand the structure, function of each molecule, each atom in our body had been the objective. The whole life sciences fraternity is involved in this. Basically, our aim is so that we virtually peep into the functioning of the cell, that how the molecular mechanism, how the molecular pathways are functional. But during 21st century, we have achieved it to a reasonable extent. As you see, if I go to a next slide, man to molecule, our endeavors had been that we explore and understand or decipher the structure and function at the molecular level. I think it is self-explanatory: organs, systems, organism system, organs, tissue, cells, molecule, and then epigenetics. When I say molecule, let me come to the DNA, then epigenetics, whether it is down the line or it plays a different role which influences the expression of our genes, so on and so forth. And how we could achieve that? We could achieve that with the advent of many new specialties, many new disciplines, multidisciplinarity, interdisciplinarity, new areas like omics technology. I think whether it is physiomics, whether it is radiomics, or whether it is genomics, all omics, synthetic biology, molecular imaging, and certainly biocomputation, big data analytics, and certainly the larger participation of physicists, chemists, mathematics people, computer scientists, etc., etc. And above that, one technology which is overarching, what we say is the artificial intelligence, which functions or which becomes effective by using IoT and big data. So overall, if we see all these technologies or techniques or disciplines, they have come together. Now it is kind of a synergy to unravel the complexities of the human body. I think the Synergia, the name is very apt and very perfect in the modern thinking of the life sciences. Now, though I have mentioned many techniques and technologies, the time may not permit, but I'll just take you through some of the potentials of this gene editing, how this gene editing is making us learn more, making us understand more, and how it is going to revolutionize the future path of life sciences R&D. I think, as all of you know, there had been two projects in the history of mankind which have impacted us the most. The one had been the Manhattan Project. The Manhattan Project, all of you know, though it is marked by a lot of notoriety that it produced the atom bomb, but on the other side, there are many firsts which are linked to the Manhattan Project. The few could be the invention of a new element, polonium, and the whole nuclear energy is the outcome of Manhattan Project. And similar to the Manhattan Project in life sciences, the project had been the Human Genome Project. And these two projects had been the largest in terms of the money, in terms of the participation, means consortia. And they were not the multi-institutional projects, they were the multi-continental projects. And the Human Genome Project gave us the understanding of the human genes, DNA, nucleotide. Ultimately, we could understand the insight of sequence of about 3 billion base pairs. It also gave us the understanding of underlying code, which determined how complex biological systems are and how they act and how they read. And also gave the better understanding of the human health. And one thing which SNP, single nucleotide polymorphism, which we have and which makes us different, had been instrumental in opening a new field, what we say personalized medicine, which I shall be addressing to some extent in my subsequent slides. Let's say gene editing. Till now, we could understand how it functions. If I know the mechanism, and I know how to repair, and if I know how to edit, what else I need, then I can play the way I want. And today we have that kind of a capability of understanding, of repairing, and also editing. To share with you some of the examples, to be make things very simple, it is just like what we do in the word processing, MS Office. You know, it is so easy to cut and paste, to replace, or to edit. And similarly, now it is possible that we can play with our sequence, genetic code, and we can knock out genes. Let's say scare, you just remove, cut E, and scare becomes scar. I want to say that the real whole meaning has changed. If you see another example. Hello,
sir, yeah, sir, your slide is not moving, sir.
But it is moving in my computer. Not moving, it is showing first slide only.
Yes, sir.
Really?
Yes, sir.
Stop. Just give me 1 second.
Okay, sir.
Just give me 1 second.
Thank you, sir. Okay, sir.
The participants are saying the slide is not moving. But they are moving in my computer. You
sir,
can't
sorry
see.
to interrupt. Sir, I guess you have logged in from 2 devices. So
Yes.
is it possible that in one device it's a slide share, but in another device which is presenting on the screen, it's not there? So
No, but I'm insisting I'm only on the one slab machine. The other machine is just static. I'm not using that. Yeah, I can close that. क्यों नहीं move हो रहा है? कुछ होगा है? Now just see.
Yes, sir. Now it's moving.
Now it's moving.
Yeah.
Now it's moving.
Yes.
Now you can see.
Yes, sir.
Moving.
Yes, sir.
Okay, now
Yeah,
I think
yeah.
rather than going back to you could see these slides. Now try to correlate what I spoke. Ultimately, man to molecule and molecule to man. You must have read Craig Venter, who did made the synthetic DNA which could replicate in vitro. That kind of a technology is there. Now the journey is from molecule to man. In times to come, we may have the synthetic DNA or synthetic microorganisms. I think I told you the new technologies, new areas which have creeped in and which are working in synergy to make us understand the complex biological systems or the functioning of the human body, like synthetic biology, omics techniques, and molecular imaging, big data analytics, biocomputation, and overall by artificial intelligence and Internet of the Things. And there are many techniques which have creeped in. I think I told you about gene editing. Then I told you the Human Genome Project, what we could learn from the Human Genome Project. And after this project completion, what kind of understanding and the techniques which we have to understand the biological systems, and after understanding, to repair the genes or the any defect, and not only repair but also we can edit the way we want. The examples which I was giving, just like how do we do the word editing, just cutting, pasting, and replacing, and you can see just by changing small one or two genes, we can really change the this phenotype of the any animal or insect. I think I'll move to the next now. What all this gene editing can do? Gene editing, particularly you all must have read the Crispr, the scissor, the gene scissor, which the tool which we have. And the originator, the two ladies, they won the Nobel Prize in Chemistry for this.
Excuse me, sir. Excuse me, sir.
Yes. Yes.
Have you moved the slide, sir?
Yes,
It's
I have
not,
moved.
It's only showing artificial intelligence slides, sir.
क्या हो रहा है यार, इसको बहुत प्रॉब्लम है. इस स्लाइड शो में नहीं जा रहा, वैसे कर देते हैं. Let's come out of the slide. Let's come out. अच्छा, now it is moving. Now moving.
Now it's gene editing.
Human Genome Project.
Yeah, yes, sir. Yes, yes.
Gene editing.
Yes, yes, sir.
I think now you bear with me. You may not be able to see the full screen, but we will go like this, right?
Okay, sir.
Okay. Now I come to the CRISPR. This is the technique which all life sciences students must have read and must be knowing. This is the wonderful technique which we have in our hand, and people are playing with this. This was invented by two lady scientists, Emmanuel and Jennifer, and they got a Nobel Prize in Chemistry in 2000, I think 20. I think the year may be wrong, but this is revolutionizing the gene editing process. And you can play at different levels of gene editing, either transcriptional modification to the epigenetic modification. And this will not impact only the humans. I think we can make use of this technique in agriculture, in environment, in healthcare, and in biomanufacturing. And the main beauty of this technique is that it is very easy to apply. It has a speed and it has an accuracy of gene editing, much more than the techniques which we had earlier. And the prediction is that the outcome of this technique is yet to be seen by the world. And daily, you see a lot of articles appearing and see that this technique is maturing every day. and its capabilities are expanding every day. If we see how it can impact the agriculture, you can have the pest resistant varieties. You can how you can make it, you can play with the genetic code of the plant, and you can make the pest resistant varieties. The example which I am showing, the Rasthali banana plants, they have been engineered and regenerated from the organic cell suspension, and this is being done in India. This slide is from the Indian lab, one lab, Nabhi, which is a, I think, ICMR or ICAR lab in Mohali. Those kind of things are reality now. You see the grapes, this gets gray mold. It's very deadly disease now. We have just by deletion of one gene, we have the gene, this disease resistant grapes. And the main aim is that we should have any crop, anytime, anywhere. We want to have anything the way we what we want. We also want to have the jasmine blossoming throughout the year, and jasmine not of the one color, the color which we like. Those kind of the possibilities are going to be there in future. If we see the livestock, I think we all know the meat scarcity. We may have the genetically modified animals, which would be the large meat producing animals. We may be able to genetically modify them or take care of the extinction of some of the species by making them resistant from the disease or any other environmental effect. Means what I want to say, you can do anything which you can think or which you can imagine. Insects. What you saw, you find that now insects are very important part of our, life or the environment. We can modify the insects, which can be useful to us in pollination, in reducing the transmission of the diseases, and we can also have the dual use, the negative use of this. We can modify the insects in such a way that they can be used as a biowarfare agents, and vice versa. So these kind of things are there, and I will share with you in one of the subsequent slides how we are trying to control these insects or dictate our terms to the insects for our benefit, what we say cyborgs. Environment. I think this is a big concern for the whole humanity, not only in India, in the world. Either it is the pollution of the air or the water, or oil spillage, which is a big concern. We can have the genetically modified bacteria. Already there are many genetically modified bacteria are there who work as a bioremediator. They can remove the oil from the sea. We can have the clean water by modified microorganisms. We can have better nitrogen fixation plants or bacteria in the roots. We can have better genetically modified trees which have a better canopy, or they are better in photosynthesis, so that we would have the better air quality index. All these are the possibilities of tomorrow. I think the major impact of this CRISPR-Cas9 and gene editing technique is going to have is on the healthcare. I think I will devote a bit more time on its impact on the healthcare. Before I go to this, I'll want to share with you. You all know that the Nobel Prize of 2018 was given to James. This was given for one technique. What we say is the CART, chimeric antigen receptor T cells. This is the technique, a gene editing technique, by which we are able to, reduce remission of the stage 4 lymphoma has been demonstrated. You take out the T cells of the patient, you modify these T cells, again you re-inject, and those T cells then specifically kill the cancer cells. So this is possible because of the gene editing technique. Ultimately, we want to, use this technology for developing better diagnostic tools, better therapeutic tools, and which are more specific and easy to implement and more effective. What kind of solutions which we are looking for? This technique will not only impact the healthcare, even other things like we would have the genetically modified animals for our R&D to develop newer and better therapeutic molecules. Suppose we are not having all the animals because of lot of ethical issues, we would have the organs, in vitro organs, which will mimic the organs or which will mimic the cells, where we would be able to test and evaluate our drugs. And these are long pending diseases like maladies, which we all know, like sickle cell anemia or beta thalassemia, we may find the solutions for these diseases in times to come with CRISPR based solutions. Ultimately, what will happen? What will happen? Because as we are talking of the gene editing, one aspect, the other is single nucleotide polymorphism, means we have something specific to the individual, and we can understand the deficiency, we can repair in the individual. What I want to say, in times to come, there would be medicines which would be specific to the individual. They would not be generic medicines. So what we say that the whole everything is moving from generic to personalized, or personalized means, or precision medicine. Precision medicine and personalized medicine, they are loosely used interchangeably, but ultimately the personalized medicine. This is one of the major impact which this technology is going to have. It means that the China has said that they will put the gene sequence of the whole population on the net. It means we all imagine our the gene sequence would be available on the net. Then I would not be known as AK Singh. I would be known as AK Singh Digital. Means all of us would have our individual digital copies. Now, when we have our digital copies, we know where the problem lies. We will know which medicine or which drug would be more specific in A, and if we have to have a new biological or new chemical, then we would be manufacturing the specific drug or biological for a patient. So these kind of possibilities are becoming reality. Another thing which these techniques will tell us, means we would be shifting from reactive to the predictive. What I want to say by reactive to the predictive. Today, what happens if I get sick? I go to doctor and I say that these are the symptoms. The doctor diagnoses and he prescribes the medicine. Then is the preventive, the next step in the preventive era, which we are already there. And preventive are the where we know that this condition, this pathology might come. So we take the preventive action like vaccines. We all know that we have been taking the vaccine of polio vaccine, diphtheria vaccine, and recently we all are encountering that we are taking the vaccine of SARS-CoV-2, COVID-19. But the world will go a step ahead. A step ahead. Omics. We would like to know that in a individual, because of this genetic makeup, we would be able to predict the likelihood of any disease showing up at a later date. So we want to move from reactive, preventive to the predictive. And for the predictive, we would be able to anticipate and prepare for its management. These two things are happening. When we go from reactive to predictive and generic to the personalized, another aspect which will be creeping in is that we would be moving from chemicals to biologicals. Means the drugs will not, all drugs will not be chemicals. Lot of drugs would be biologicals. And even today we have many biological agents which we use for therapies, like you must have seen the cytokines. We have many growth factors. We have many monoclonal antibodies. Even for the COVID-19 treatment, I think the former president of America was given monoclonal antibodies. So biologicals, there would be shift from chemicals to the biologicals. When we say that biologicals, it will bring many issues or many concerns and challenges. I think this slide just to share with you what human genome engineered humans, you know, you will have the designer babies, or what we had been saying, that the child of your choice. And one article which came in Nature in 2016, they say in times to come, to produce babies, you know, you don't need the genetic cells, you don't need mating, you know, you can make love with your partner for anything and everything, but not for the babies. These kind of realities would we would all be witnessing. I think I'll leave the concerns. Still, this technology is maturing, and I'm quite confident in times to come we would be able to overcome all the concerns of this gene editing technique. Now, let's say what are the future challenges, which I was saying of the biologicals, because we would need biologicals which would be specific, which would have a lesser half-life, which have to be precise, and which have to be specific, and they are to be delivered in the lesser time. Means we cannot wait for biologicals for months together. We need them in days or in the weeks. So a new area which is emerging in the life sciences is biomanufacturing or biofoundries, and this utilizes, you know, the prokaryotic cells or cells in culture to produce molecules, antibodies, cytokines, or growth factors. What we say that we will have programmable microbes where we would be producing the peptides for therapy. We would have animal cells where we would be generating specific monoclonal antibodies, or embryonated chicken egg where we would be developing viral vaccines, or organoids, which I said means organs in the culture. But everything would be there. But this is not going to be so easy, because you have to maintain the aseptic conditions, and they should be of high fidelity, because biologicals you cannot have any kind of a zero tolerance kind of molecules would be there. I won't go into the details, but we all know that would be time when we would have organs on the tip. We would have organs, you know, mini brain, mini intestine, which would be, you know, mimicking the natural organ, and they would give us more flexibility to do R&D and understand the mechanism further. Biomanufacturing, the challenges would be, it is not going to be scale up. 10 lakh paracetamol ka tablet banao, wo sab mein bant gaya. No, the time would be scale out because of the specificity. Maybe one molecule for one cohort, one molecule for one family, or one molecule for one specific person. These kind of things would be required. I think regional availability, I told you, and in silico modeling, because for such molecules, we would not have the privilege or liberty to try in the cultures. Means all these things would be done in silico modeling. Means you do them in vitro, so that when we go for the real or correct molecule manufacturing in biofoundries, we do not want to make any mistake or without any deviation. So another thing which will creep in is the fail fast. Today we may have the luxury of, you know, taking more time to develop anything, but the way the world order is changing, now the time has come. If we are not able to do anything, or we are not able to establish, I think let's fail fast, so that we know it is not possible. Or what we also said, if not only fail fast, that we fall forward, because if we are not able to do it, let's learn and change it. This is a new thing which we have to do. I think you are the young people. Never ever stick to a thing which you are not able to do it. Never ever justify, because in R&D, I see in many R&D projects, if scientist is not achieving the success, but he hides, he never says that I have failed. But failure is the part of the game. It is better to fail fast, and so that I can correct it and I can shift to next thing, rather than hanging on that issue. High fidelity and high security. Because when I say high security, the data security or the human data security is going to be a big concern, because my gene sequences would be available with the hospital. I would like that it is known to the need to know basis, one, because that would make the basis of the future specific drugs. And this may open a new area where people may like to hack the data of an individual for wrong purposes. So, data security of the human gene sequence may be another concern in times to come. Even the market dynamics will change. The government may not be funding all these biomanufacturing. There will be crowdfunding. The crowds will be pooling the money and it will be funded. And there will be pooling of the resources, because this in vitro culture is not going to be so easy, because it's a costly affair, because one machine has to prepare different molecules over a period of time. Shifting from one molecule manufacturing to other, you need so many changes, because so that there is no cross contamination. One. Number two, then now when we see the culture, one is the fed culture, the other is the continuous culture. So we have to see, because the fed continuous culture would be that it is continuously culturing and we are taking out the product. Fed culture means you have cultured and there is a gestation period. Means adaptive manufacturing, there will be many things which will creep in the manufacturing, the funding, who will own the IPR is going to be an issue. Tomorrow, the crowdfunding or any country which has the technology, they may deny this technology to their adversaries or the people whom they do not want. And ethical issues, I think I need not to go into that, and regulatory issues. Ethical issues means what kind of people we would be developing, what we say the designer babies, or what kind of the molecules, whether those molecules should be used or not. Because when we understand the gene and we have the capacity to repair and edit, we would have the capacity of developing superhuman beings. Now, which another aspect which I will share with you. What we say the human enhancement. This technique would also strengthen this aspect. Ultimately, making people better or making better people. I think we want to do both. Making people better, we would do one by the gene editing and other by augmentation. Already the R&D is on. We in DRDO are in many of the aspects which I have shared now, or which I will be sharing. Human enhancement, enhancing the capacity and the capability of a person. What do I mean by capacity and capability? Capacity is doing newer things, and capability means doing at the larger scale. And human enhancement, we venture by doing the physiological enhancement, by cognitive enhancement, computational. We do the automation and robotics. I think you can see some examples. In times to come, we will have the RFID chip under our skin, which would be used to open the locks, which would be used to access our bank accounts, to the access control, etc., etc. I think augmented vision. There was a big there was a one video on the WhatsApp which was circulating, where in times to come, we would like to see the 360 vision. Now we cannot see the backwards. We would like to see the 360 vision around us, so that I have the better situational awareness in critical conditions, either when I am on some job or when I am in the field of the combatant, the soldier in the field, or when a fighter aircraft, the pilot is flying the fighter aircraft. Smart contact lenses, which will not only make us see the larger view and large view, but we would be able to record the videos. Smart drugs, which will enhance our physiological capabilities and capacities. Exoskeleton. DRDO is working in a big way on the exoskeleton. Giving the strength outside by which person would be able to do repeated works. Means to make a simple example, if I can lift 30 kg 100 times, 30 kg, 100 times to certain height. By exoskeleton, I want to lift 60 kg 200 times. These kind of things, and which will also permit me to carry larger load to the difficult terrains, or which will also protect my skeletal system. I think 3D printed parts and organs, all brain-computer interface. This is a new area which is emerging. Means where we want to have the communication from the brain to machine without any wire, or we want to have the direct communication from a machine to the brain. It means that our brain would be processing the information in the data, and we would be able to transfer it. Or we would augment our brain by chips or by other devices, so that we do the better data processing and computation and take better and quicker decisions. Edermis. This is something where we want to communicate, we want to develop the interface of communicating from the skin to the machine, because this technology is very much required in the exoskeleton, means where machine and man would be interfacing. I think I will leave this. This slide shows the various technologies which are required in augmentation and their maturity level. I think I can leave it, but certainly there are many technologies which are at the higher maturity, and there are plenty, I think larger numbers are still maturing. So I think in next 1 decade, we would have the super kind of a human beings, which I was saying. Ultimately, when we would be able to achieve all this, then we would have the cyborgs, where the person would be enhanced genetically and cognitively, and we would have the robotics. Means we have the soft exo and endo skeletons. That's what I said. And intelligent prosthesis, where where I have to turn, the prosthesis will anticipate, will predict my thinking and take actions accordingly. It means already there will be a direct communication from the brain to the prosthesis. I think all of you must have seen this living human cyborg, where this Neil was born colorblind, but now he can see the colors. And what he see, the information, the color is directly fed to his brain. And to share with you, he is the authorized human cyborg known, and this is the image which appears on his passport. So these are the realities. These are not fictions now. What I was talking of, the insect cyborg, it could be the insect cyborg or the small animal cyborg, where a microelectrode is planted in the brain, and a small trigger electric impulse is given, by which we control their this happiness center, one center, by which we will make animals move into the direction which we want. And they are utilized in earthquake detection. They are utilized in explosive detection. They are also utilized if there is any living man who is buried under earthquake damaged buildings or crevices. These things are reality people are using. But the insect cyborg is still, the R&D is going on. In tomorrow we will have such type of cyborgs which we would be utilizing for our benefit, offensive and defensive purposes. I think neural lace, which I said, this is the term given by the founder or the CEO of SpaceX, Elon Musk. He says that I would have a kind of a wire from the human brain to the machine. It means the capacity of your brain, the storage capacity, the computation, the processing capacity would be much larger. In times to come, we may have the chip where the whole Google is in our brain. That kind of a data storage and data processing would be there. And we are not making any key punching. We are just thinking and the action is being done. These kind of thinking is there, and the R&D is going on. To share with you, and these are the things. Still, the DRDO is conducting a workshop on brain-computer interface with the United States Department of Defense. So this is kind of a future soldier which DRDO looks for, where he will have the full 360 vision, head-mounted vision, helmet which will have the brain computer interface technology. He would have so many biosensors by which he would be able to predict and assess the threat of the surrounding. Then armor with soft robotic means it looks like hard. No, he will have the flexibility to work. And ultimately, you can see, tissue engineered muscular system. He will never feel tired. Means he will never feel fatigued. He will be able to operate for 24, 36 hours. He would be given superfood. He would be given such kind of energy sources. So these kind of thinking is there, and for which the R&D is going on. What I say, it is the era of augmentation, because human being is a very tricky animal on the planet. He never gets satisfied. If you see the Olympians, they stretch their physiological limits to perform, but we are not happy even with that. We want to stretch further, and the race and the fight is that we augment our capability and capacity to the unknown limit. I think after this, there would be other things which would be taking place. The last slide, which is a bit out of context, because we all are encountering Corona, this COVID-19, and which is trying to say goodbye. We all are happy to say goodbye to him. The power of life sciences, the power of biology, because I work for DRDO, where in DRDO, 95% of the DRDO enhances the kill power. We develop various platforms, various systems to kill, means to enhance the kill power. And we see the big machine guns, big tanks, big missiles. And let's say I take a bomb, 3,000 kg bomb. It will have a certain impact. It will, vanish, kill everyone, let's say in 5 kilometers, 2 kilometers, 3 kilometers, depending upon the capabilities, but certainly to certain tens of kilometers, but not the hundreds of kilometers. But the Corona, which is invisible, the havoc it has created. There is a calculation that if we separate the virus, coronavirus, which has infected any human being, whether dead or alive, if someone was separating the virus from each body, putting them in one test tube and weighing, the calculation is that it will weigh around 2 grams. I give the leverage, let's say it will weigh 10 grams. Now see that 10 grams, the havoc which it has caused in this world, still we are not able to calculate the damage which it has caused. That is the strength of the biological system. This is the strength of biology. This is the strength of life sciences. Now it depends upon the human being how we use this strength for our benefit, or more means for defensive purposes or beneficial purposes or for offensive purposes. What I want to say that in times to come, it is the life sciences, it is the biological sciences which will be playing much more important and much more pivotal role in times to come. And in the era of augmentation, it is, we do not have liberty to be reactive, or if the time has come, even not for the proactive, the time has come that we have to be predictive. Let's predict everything. Predict so that we can plan and prepare and take care of all of us. Thank you very much for patient listening.
Good morning, everyone. This is Arushi Dogra, Joint Secretary, Synergia. Thank you so much, sir, for the talk. It was really comprehensive. Following up with this, sir, can we move ahead with questions from audience?
Yes.
Sir, initiating with question 1. So since you were talking about artificial intelligence, few says it is harmful for mankind. Then how far it is necessary to prioritize it in coming future?
I think I didn't say it is harmful for the mankind. I said it is an overarching technology which is impacting all fields, all areas. It is not, let me no technology is harmful. No technology is bad. It is its usage. Let's say mobile phone, the communication technology is not bad, but its over usage is becoming a problem for all of us. So artificial intelligence, certainly it is not a bad technology. It is a wonderful technology. It's a wonderful.
Thank you, sir. Sir, following up with this, we have another question from Himanshu, that there is a shortage of vacancies in academia, and as he got to know from a fellow scientist that DRDO has opened any scientist vacancies for life sciences in years. Kindly let us know what can be done to solve this problem so as to attract more opportunities and brilliant minds to this field.
Certainly, DRDO always looks for the good people to join the family so that we can do better jobs and give better output. Those who are interested in joining DRDO, they should visit the DRDO website, and particularly the RAC, Recruitment and Assessment Center. We have a dedicated establishment which advertises the vacancies and processes for the selection. Recruitment and Assessment Center on DRDO website.
Thank you, sir. So, question from Sujal Sahu is, according to you, will a Crispr Cas9 be more advantageous for development in healthcare, which can also be used for gene editing for disadvantages of the society by making some perfect as compared to a normal being which are born with some flaws? So, should there be any governing bodies for genetic developed babies? Otherwise, it will make them more advanced than a normal baby.
Actually, this had been a matter of big concern. If you might have read in China, one of the scientists, he did some gene editing in HIV patient, and ultimately he was sacked. Actually, in such techniques, kind of a gene editing technique, it is the domain of its usage. I said these are the dual use. जैसे कहते हैं दोहरी तलवार हैं. अगर इसको हम एक अच्छे काम के लिए यूज करें, you can manage many of the diseases, you can take care of those diseases. और उसी को अगर हम गलत उसमें यूज करें, so you can really create dangerous insects, dangerous animals, microbes, because still the debate is on whether this SARS-CoV-2 is a man-made pathogen or virus, or it is a natural virus. These techniques would give us capability of modifying any not only microorganism, any animal also, and which could be dangerous. Certainly the regulation has to be there, and regulatory authority has to work under the domain of ethics also.
Thank you, sir. So, question from Navneet is that, as you told about benefits of GMOs, currently installing GMOs for human convenience, like GMO crops, is taking place at high extent. And on the other hand, we are talking about sustainable food production for enhancing biodiversity, ecosystem, and natural farming. Out of both two things, which one should be done or preferred more?
Madam, again, genetically modified crops is one aspect. Sustainable food production is another aspect, and they are not separate. Basically, they are interlinked. Genetically modified crops, our aim is, let's say, resistance to diseases, resistance to certain extreme environment, larger production. Ultimately is that we have a larger production and secured production. And that will add, or that will be a part of the sustainable food production. Ultimately, again, it comes regulation and the ethics.
Yes, sir. So, question from Aman is, instead of using cyborg insect, isn't it better to use robots?
Both have a different advantage and disadvantage. Robots, they may be able to replace the cyborgs, but making a robo to that a small size, then certain energizing them, then battery issues would come. The flexibility of the domain of the usage may come, but certainly their usage is quite overlapping. But extremes, one cyborg may be useful in a certain situation, and in certain situation the robots would be.
Okay, so thank you. So a question from Sujal Sahu is that after that the scientist was put under bars and a conspiracy that China has been using the technology of that scientist for making their army more genetically advanced as compared to a normal being.
I may not be aware of any such thing. Sorry.
Okay. Okay, sir. Thank you so much, sir, for responding the questions enduringly. Now I would like to call.
Arushe,
Yes, sir.
Dr. Indrakant has raised his hand. Maybe his inquiries.
Okay, sir. Just a minute. Indrakant, sir, are you there?
Hello, my voice is audible?
Yes, sir.
Yes.
Audible.
Yeah. Thank you so much, Dr. Singh, for such a wonderful information and recent updates about all the new technologies for human welfare. I have just one more query because you are heading R&D. What best opportunity for all of us as a young faculty for research and development, and especially funding aspects, especially in the college, because many of you, I know, because I also running a small life science lab working on drug discovery in Deshbandhu College itself. I met you a long time back when you were in INMAS. But now I just wanted to know that what is the best opportunity and how we can avail those facility of small funding. Because in college level, we have very limited funds. But many of our faculty member and researcher wanted to go ahead with the, life science research.
I'll respond. I hope principal is also listening to me. Is he there?
Yes, I am very much here, Dr. Singh.
Okay. Now, DRDO in a small way, we also fund R&D. And to share with you, Manisha ka ek project jo hai, which is being considered now. She has submitted a project for funding. Actually, your main assignment is teaching and then R&D. So DRDO funds the projects which are of interest to us. Certainly the areas which interest us. First, you should find out what are the areas where DRDO is interested and where DRDO will fund to the larger extent. But we also fund to smaller extent new coming up areas, newer areas where you would be able to generate good knowledge, which would be useful tomorrow. But what happens then, there has to be some threshold level of facility and the space available to you in the college. Because I also know it is not hidden, because colleges, they may not have that kind of infrastructure. So what can be done, that in a one college, let's say Deshbandhu College, which is, we all are proud to know Deshbandhu College, बहुत पुराना और बहुत ही बेहतर college है. उसमें than exploring 10 area, आप लोग सब मिलके फैकल्टी मिलके कहें कि we will be working in 1 or 2 areas, उस एरिया को हम लैब्स उसमें आप बनाएं और उसके लिए जो फंडिंग एजेंसीज है उसमें फंड मांगे, तो उसमें क्या होगा, as you go up vertically, your claim would be more justifiable. उसमें क्या होगा कि आपको फंडिंग एजेंसी भी ज्यादा पैसे और ज्यादा फंड करना चाहेगी. आप rather than doing कि मैं कैंसर पे भी काम करता हूँ, मैं ड्रग डिस्कवरी पे भी काम करता हूँ, मैं जीन एडिटिंग पे भी काम करता हूँ, मैं बॉटनी में भी काम करता हूँ, उसमें क्या होगा कि वो फ्रैक्चर्ड एफर्ट्स रह जाते हैं, उसमें कुछ निकलता नहीं है. तो आप 1-2 एरिया बनाएं और डीआरडीओ से फंड सप्लाई मांगे. डीआरडीओ में जो फंडिंग के तरीके हैं, एक है ईआर, एक्स्ट्रा म्यूरल रिसर्च, ईआर, उसमें आप अपना फंड मांगे, डीआरडीओ विल scan or they will review the project and fund it. एक है लाइफ साइंसेज रिसर्च बोर्ड, LSRB, उसका वेबसाइट पर फॉर्म अवेलेबल है, उसमें आप फंड सप्लाई करें, दैट वुड बी कंसीडर्ड एंड वी वुड बी फंडिंग. एंड देयर हैड बीन मेनी इंस्टेंसेस व्हेन DRDO हैज फंडेड मेनी कॉलेजेस इन पास्ट. और उसके लिए आप जो भी दिल्ली बेस्ड लैब्स हैं या बाहर की लाइफ साइंसेस बेस्ड लैब्स हैं, आप उनसे इंटरेक्ट करो, ट्राई टू अंडरस्टैंड वेयर यू कैन अलाइन योर एक्सपर्टीज एंड देयर रिक्वायरमेंट एंड वाइस वर्सा. उससे फंडिंग वुड बी मच मोर इजी.
Thank you, sir. Just supplement to this, I would like to inform you that with great support of the present management of this Bandhu College and our principal, we have developed a very good infrastructure for research. And last 10 years, we have all the basic facility for molecular biology as well as in silico work. And last 5 years, we have done wonderful good work. Some of the tools also we developed for neuropeptides and related to health science.
I'll suggest what you do. Then okay. Then we need to update it. What you do, you can call the director in mass, director DEPAS, director TIPR. उनको एक दिन अपने यहाँ visit कराइए, because the screening level पे they are the people who are there. If they know your capabilities, कितना infrastructure है, that will help them in processing the projects for approval.
Great. Thank you so much for your kind suggestions. And do we have any, kind of suggestions from you where within the DRDO different labs, specified lab, can we collaborate with them?
You can collaborate with anyone. DRDO is open for any collaboration. In fact, we look for collaborations. लेकिन collaboration is always a two-way communication. उसमें एक हाथ ले और एक हाथ दे. तो उसमें क्या होता है कि दोनों ऐसा सिचुएशन आप देखो in what way you can help them in their projects, because वो बहुत सी ऐसी चीजें हैं जो स्क्रीनिंग की हैं या कोई बेसिक चीजें हैं which they would like you to do for them. उस चीज को आप बात करके जानिए, उस चीज को आप अपने कॉलेज में करिए, they would be more than happy to collaborate with you.
Thank you.
और दिल्ली यूनिवर्सिटी से DRDO का बहुत गहरा नाता है, बहुत प्रोजेक्ट्स हैं और बहुत कोलैबोरेशंस हैं.
जी. Thank you so much, sir. I'll get back to you with all the proposals, sir. Thank you so much. Over to Arushi.
Yes, Arushi, go ahead.
Thank you, sir. Now, I would like to call Mr. Akash Kumar Sani, President Synergia, to formally introduce conveners, co-conveners, and office bearers. Thank you. Over to you, Akash.
If the principal and the convener they permit, may I leave? Hello. I would like to peel off now.
Sir, sir, just a vote of thanks, sir. Sir, just a vote of thanks, please. Thank you.
Quickly.
Thank you. Vaishali, please continue.
Thank you, ma'am. So gratitude is one of the least articulate of the emotions, especially when it is deep. Good afternoon, everyone. So we have reached towards the middle of the inauguration ceremony, although we have our events lined up. But I, Dr. Vaishali Chakral, co-convener of this society, take this opportunity to put my gratitude into words. So first of all, I would like to thank Almighty God for making today's function a great success and for the wonderful talk by Sir. On the behalf of Life Sciences family, Deshbandhu College, University of Delhi, I would like to extend my heartiest thanks to our Honorable Chief Guest, Dr. Ajay Kumar Singh, Sir, Director General, DRDO, for his presence in the function. Thank you, Sir, for enlightening us with your immense knowledge on life sciences. You are an exemplary person and we have a lot to learn from you. Wholeheartedly, I must thank our principal, Sir, Dr. Rajiv Agarwal, a humble person who is an inspiration to all. I would also like to thank Dr. Dharmendra Kumar Malik sir, Dr. Manisha Sengar ma'am, Dr. Deepti Gupta ma'am, Dr. Anju Chhabbar ma'am, Dr. Kiran Bala ma'am, and all the teaching staff and non-teaching members of botany, zoology, and chemistry department for their endless support and guidance for organizing an event on the founding day of our society. Special thanks to Dr. Bonika Bajaj ma'am, Madhurani ma'am for the technical assistance. Heartfelt congratulations and a big applaud to our dedicated students, the office bearers, Akash Kumar Sahani as president, Vikram Sehrawat as vice president, Ankur Bhardwaj as secretary, Arushi Dogra as joint secretary, Chahat Kalra as editor, Manika Chauhan as cultural secretary, Pavitra Nanda and Anshul Jolania as technical heads, and all the council members of Synergia and the volunteer Vishal for your hard work, which has made this day a memorable one for all of us. And it's not over. We have wonderful events lined up for today and tomorrow. So thank you so much, sir. Thank you so much and have a very good day.
Okay, thank you very much. Okay, may God bless all of you.
Thank you, sir. Thank you,
Thank you so much, sir. Thank you, sir, from the on the behalf of the council as well. Thank you, sir.
Thank you.